Hey there, Cloud Crusaders. Welcome back to Hack the Cloud. Today, we're going to untangle the wild world of routing in Google Cloud Platform. It's like being a traffic cop, but instead of cars, we're directing packets of data, hopefully without any road rage. What is routing? First things first, what the heck is routing? Think of routing as the GPS for your data packets. It's all about selecting the best path for your traffic to flow, whether it's within your internal networks or between different networks. You don't want your data getting lost in the digital wilderness, right? The star of the show, the router. Enter the router. This little device is the ultimate traffic cop, allowing communication between different networks. It's like the wise old sage of networking. Oh, you want to go that way? Sure, I'll help you out. Meet the Cloud Router. Now, let's introduce the Cloud Router. This is GCP's very own traffic management system that lets you dynamically exchange routes between your virtual private cloud VPC and your on-premises network using BGP. It's like having a GPS that updates in real time. No more yelling, "Are we there yet?" Routing tables, the data map. Next up, we have the routing table. Think of it as the encyclopedia of routing information within a network. It's where all the important addresses are stored, like a digital who's who of networks. Routing modes, static versus dynamic. Now let's talk about routing modes. We have two types, static and dynamic. Static routes are like that stubborn uncle who refuses to change his mind. They're fixed and don't update unless someone manually adjusts them. On the other hand, we have dynamic routing. These routes update to reflect the current state of the network. It's like the cool aunt who's always in touch with the latest gossip and knows the best routes to avoid traffic. Route summarization, less is more. Now, let's talk about route summarization. This is all about reducing the number of routes advertised to your neighbors. It's like condensing a 3-hour movie into a 2-minute highlight reel. Short, sweet, and to the point. Next hop, your packet's next destination. Next up is the next hop. This is the address of the next router in the transit route of a packet. It's like telling your data, okay, you've reached the first stop, now hop on over to the next router. Software-defined networking, SDN, the cool kid on the block. Let's not forget about software-defined networking, or SDN. This is a software-based networking approach that uses APIs to communicate with the underlying infrastructure to control network traffic. Think of it as the cool kid who brings a tablet to class and runs the show. Border Gateway Protocol, the internet's traffic guide.
Now, let's set sail into the world of BGP, or Border Gateway Protocol. This is the path vector protocol of the internet. It's like the captain of a ship navigating the vast sea of data, using TCP port 179 to steer the way.
Autonomous Systems and Numbers, ASN.
Next, we have Autonomous Systems, AS, collections of connected IP routing prefixes under the control of network operators. And every AS gets its very own Autonomous System number, ASN. It's like giving each network its own VIP membership card.
External BPEs, Now let's talk about BGP connections. We have external BGP, which is formed between different ASs, and internal BGP, which is all about connections within the same AS. It's like having a family reunion with your cousins on one side and your close friends on the other. Multiple exit discriminator and AS path prepend. Next, we have some BGP attributes, multiple exit discriminator MED, and AS path prepend. MEND is like a non-transitive ticket, where the lower metric wins, and AS path is mandatory, shorter paths are preferred. It's like a race where everyone wants to take the shortcut. Multi-protocol label switching, the label king. Let's talk about MPLS, or multi-protocol label switching. This is a method that uses labels instead of IP information to transmit packets across the backbone core at high speed. It's like giving your packets a crown and telling them to strut their stuff on the runway. Bidirectional forwarding detection, BFD. Finally, we have bidirectional forwarding detection, BFD. This protocol detects failures quickly on links when enabled. It's like having a super fast referee ready to call out any fouls in the network. Wrap up, routing your way to GCP. So there you have it. From routing tables to BGP, MPLS to cloud routers, GCP offers a smorgasbord of routing options for your data. Just remember, picking the right path can save you from getting stuck in a traffic jam of data. Thanks for tuning in. If you found this video helpful, be sure to hit that like button, subscribe, and drop your thoughts in the comments. What's your favorite way to route your data? Until next time, keep navigating the cloud like a pro.